Welcome viewers, in this video we will see the number of possible tree of a given graph available in the network topology. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In network topology, how to identify the number of possible tree in a graph. For a given network graph, it is possible to write several trees. The number of possible trees equal to the determinant of matrix A and transpose of matrix A. So we can draw the several trees. The number of possible trees can be identified from this formula. Determinant of A multiplied by transpose of matrix A. The A is nothing but reduced incident matrix. A transfer is transfer of the matrix A. So we need to find first the reduced incident matrix. So the reduced incident matrix can be obtained from the oriented graph. Now we'll see what is the oriented graph. So consider this oriented graph. Oriented graph means the given network replaced by the line, straight lines, is called a graph. The directions are available mean oriented graph. We are able to know the what is the direction. So network replaced by line graph if the direction also available in oriented graph. From that we can able to identify the incident matrix. So this matrix will give the information whether the network is connected, the network and branch is connected, the current is flowing towards the node or away from the node. That can be identified from the incident matrix. For example, this is the three nodes. We consider the three node A, B, C. Node means junction of elements. There are four branches available. Branch means connected between the node. The element connected between the node is a branch. 1, 2, 3, 4 branches are available. 3 nodes and 4 branches are available. So we can able to form 3 cross 4 matrix. So here the node A, B, C is available. Here branches 1, 2, 3, 4 is available. Now we need to check how the node in node 1, how the branch 1, 2, 3, 4 are connected. Based on that we can write the value. First to consider the node A. Branch 1 and 4 is connected here. Branch 1 going away. Going away means plus 1. This is also going away. Fourth branch. So plus 1. Branch 2, 3 is not connected with the node A. So 0. So not connected means 0. Going away means 1. Going towards means minus 1. Going towards is minus 1. Going away is plus 1. Now consider the branch B. Here node B. 3 branches are connected. 1, 2, 3. 1 is going towards minus 1. 2 is going away plus 1. 3 is going away plus 1. 4 is not connected 0. Then consider the node C. Here also 3 branches are connected. 2, 3, 4. 1 is not connected 0. 2 is going towards. 3 also going towards. 4 also going towards. So minus 1. Going towards means minus 1. So from from this tabular column we can frame the complete incident matrix having 3 rows, 4 columns. 3 node mean 3 rows, 4 branches mean 4 columns. So this is the complete incident matrix given by the notation A suffix A. But what we need is reduced incident matrix. Reduced incident matrix means any one row can be eliminated. That is called reduced incident matrix. We can eliminate first row, second row or third row, anyone. Here we will eliminate the third row. Third row is eliminated. We consider only first and second row. So this is called a reduced incident matrix. Now we can go to the condition. Determinant of A multiplied by transpose of A. From that we are able to find the number of possible trees. So determinant of matrix A multiplied by transpose of matrix A. So this is the matrix A, reduced incident matrix, what we discussed, what we got earlier. So this matrix is written here. Then transpose of matrix A means rows and columns are interchanged. The row is written as column, second row is written as second column. 1 0 0 1, the elements available in row written as 1 0 0 1 first column, elements available in second row written as second column. This is called a transpose. Rows and columns are interchanged. Now we need to multiply this. How to multiply? Elements in the first the first row elements are multiplied with first column elements. These four elements are multiplied with these four elements. The row elements multiplied with column elements. 1 into 1 plus 0 into 0 plus 0 into 0 plus 1 into 1. So that is written 1 into 1 1, 0 into 0 is 0, 0 into 0 is 0, 1 into 1 1. Then second element is same first row element multiplied with second column elements. 1 into minus 1 minus 1, 0 into 1 0, 0 into 1 0, 1 into 0 also 0. Now the second row, how we can do? The second column, second row elements are multiplied with first column elements, then second column elements. So 1 into minus 1 into 1 minus 1, 1 into 0 0, 1 into 0 0, 0 into 1 0. Now repeated for the second column. Minus 1 into minus 1 plus 1, 1 into 1 1, 1 into 1 1, 0 into 0 0. Right? First row elements multiplied with first column elements, then second column elements. Second row elements multiplied with first column elements and second column elements. So that we'll get the 2 cross 2 matrix. So 1 plus 1 2, here minus 1, here minus 1, 1 plus 1 plus 1 3. Now we need to find the determinant. Now we need to find the determinant of this matrix. 2 into 3 minus of minus 1 into minus 1, these two. So 2 into 3 is 6, minus 1 into minus 1 1, but here minus is there, so minus 1, 6 minus 1 5. So we got the value. So the given network have 5 possible trees. So this is the maximum possible trees is 5. From this formula we are identifying. Now we'll see these 5 possible trees. What are the 5 possible trees? We'll see one by one. So these are all the 5 possible trees. The first one, 3 nodes A, B, C, branch 1 and 4 is connected. The tree is the subset of the given oriented graph. It should not be closed. It should not be closed loop. There should not be any closed loop. We should not close the network. Then only it is called a tree. If we cannot write a line here, it should be open loop. So here branch 1 and 4 is considered. Here branch 1 and 3 is considered. Here branch 1 and 2 is considered. So 1 is available in all 3 trees. 1 with branch 4. Branch 1 with branch 3. Branch 1 with branch 2. Like that 3 possible trees are written. Another 2 possible trees. Total 5 trees. The 3 trees we discussed. In the 4th tree, again node A, B, C, branch 3 and 4 are connected. Here branch 4 and 2 is connected. We cannot connect here. It become closed loop. We cannot connect here. It become closed loop. We cannot connect here. It become closed loop. The condition is we can connect less number of branches in such a way that it should not be closed loop, so that we are not able to connect the line here and here also. So these are all the 5 possible trees. In the first possible tree, first 3 possible trees, branch 1 connected with branch 4, branch 1 connected with branch 3, branch 1 connected with branch 2. 1 4, 1 3, 1 2, like that connected. Not a closed loop. The 4th and 5th tree, 4 and 3 is connected, 4 and 2 is connected. So like that we can connect all possible trees. Then we can verify there are 5 possible trees. We already got the number. Accordingly we drawn the 5 possible trees. So in this video we discuss what is the maximum possible tree for a given oriented graph. We consider one oriented graph. From that we identify the complete incident matrix. By eliminating one row we obtain the reduced incident matrix. Then we apply the formula matrix determinant of matrix A multiplied by determinant of transpose of matrix A. In that we got the value 5. So the maximum possible tree is 5, and also we discuss the wall diagram for the all possible 5 trees. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.